All right, in this next example, we're still thinking about our dot plots, but instead of interpreting results here, we're going to be asked to generate a frequency and relative frequency distribution, fill in that table, and then we're going to be asked to construct a dot plot. Right, so in this example, the following data represent the number of available cars in a household based on a random sample of 25 households. Okay, so first we're going to use this information to fill in our frequency distribution in this table. Okay, so 0, 1, 2, 3. 1, 1, 2, 3, 4, 5, 6. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3, 1, 2. 4, 1, 2. 5 shows up exactly once at the end. Okay. Now before we go any further, before we start calculating our relative frequencies, we want to make sure that our total is correct. Right? So we're going to add these up. 3 plus 6 is 9, plus 11 is 20, 22, 24, 25. Right? So we total 25 here. Right? And if we look up at our original data set, I have these kind of grouped into groups of 5 to make it easier to count. Right, so 5, 10, 15, 20, 25, everything matches, so we're good. Again, I strongly recommend doing that before you go on to the next step in your problems when you're creating your frequency and relative frequency distributions. All right, so our relative frequency then, we're going to find by dividing. Again, we're taking our frequency divided by the total. So 3 divided by 25 gives us 0.12. No rounding needed here. 6 divided by 25 is going to give us 0.24. 11 divided by 25 is 0.44. 2 divided by 25, 0.08. 2 divided by 25, 0.08. 1 divided by 25, 0.04. Again, if we add these all up, they add up exactly to 1, or if we think about them as percents, 12%, 24%, so on and so forth, they add up to 100%. All right, now we're asked to construct a dot plot to show the number of cars per household. All right, so 0, we have 3, so we're going to put 1, 2, 3. For 1, 1, 2, 3, 4, 5, 6. 2, we've got 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 1, 2, 2, 1, 2, and 1. So my lines aren't perfectly straight there, but we do see our frequency represented in the height of our different dots in each of these stacks here. All right, so to finish off our discussion of dot plots, the first example we talked about interpreting them. This case we actually constructed it. You're going to be asked to do a combination of different things as we're going through your homework. The advantages of dot plots, they show individual data values, right? Because each of those dots represents an individual data value. It helps investigate the shape of our distribution, so we can kind of see a general shape here. Disadvantages of dot plots, ultimately they're not as common as other graphs. The next type of graph that we're going to talk about is going to be the most common. And another disadvantage, it could be challenging for a data with lots of individual data values. If we had 100 different data values, right, we would have a pretty large dot plot, especially if we had some high frequencies. Right? So dot plots are especially good for smaller data sets where we want to see our individual data values, but they're not as common, and especially if we have large data sets.